Good evening, ladies and gentlemen. Thank you very much for giving me a voice. My name is Gabriel Sorosi from Bengal University. I will today talk about microbial hydrogen production, basing on a summary on lectures given on this webinar from the December. I am planning to write the article to renewable uh, to uh, to chemistry education research practice in Royal Society, where I compile my lectures, and I invite you to send also the uh, the summary of your lecture with for me, and the compilation of this lecture will send a submission to this journal, and we'll have a article about our webinars, which helps us to get the grants fund. Today, I will talk about 6 months of my 6 months of my lectures. The lectures I write about my scientific achievement in hydrogen production, and basic on achievement review of recently published papers from 2020 to up to now. My my discussion about firstly was there was describing what is dark fermentation, why I choose, because dark fermentation is a special kind of a metal production of allowing process. So process of microbial anaerobic decomposition of different organic waste into, in case of dark fermentation, trans is stopped on process of acidolysis. Thus, as part product is gaseous part. In this gaseous part is hydrogen. After describing about limitation, going from Darwin and which says that cannot be obtained higher than 33% due to thermodynamic limitations by naturally grow bacteria. I say the limitation to compare other methods because we should process our waste to replace conventional fossil source of our life or source of chemistry and fuels, and we need to replace and clean our surroundings due to the organic waste, both plastics, carbon dioxide, which is coming for our for burning and to combust our also our uh, fossil fuels, which were biomass, old biomass, which was pre-treated due to millions years of our Earth and down ground as the source of carbon oil. Now, if when we deplete it, we are forced to change our organic waste, which were fossil fuels, material, green chemistry, using the surrounding organisms as one of part, to obtain using this carbon dioxide. And microbial are applied plants like biophoto algae, applied uh, bacteria like microalgae, dark fermentation, microbial electrolysis, and this using plenty of materials. In case of dark fermentation, we our product are mostly sugar because model plant initially was that sugar comes to the block to the pyruvic pathway into acid and giving hydrogen with the mostly occurring butyric acid, but less productive, that less probable acetic pathway. But therefore, after some time, after 2018, the research shows that also lipids can give, which gives also some big source, because lipids material are ways are big after issue, because lipid waste comes after macroalgae. Algae can split water during first lifestyle and cultivating, and some part can be as medicine, and some part as biofuels. And this what is not going to biofuels after extraction, the waste is very good material for the fermentation of other microbial cells. Microbial cells produce some boiling potential during decomposition potential, which is enough to split some products like ammonia or acetic acid. So we can combine this method, and now many works combining these all methods to produce hydrogen, to make from 1 kilogram of waste maximally high production of hydrogen. Besides hydrogen, we need to replace the phosphorus, other material, biofuels, which can biobutanol, which are algae, and also there are fungi, which can, for example, lignocellulose waste very well separate from lignin and give only cellulose and hydrocellulose, which is suitable for fermentation, because lignin derivative blocks. So we have to avoid. And due to this combination of these different bacteria, we can obtain method which is suitable and offers alga's advantages. This that take this carbon dioxide and absorb heavy metals. So these are microbial are very irrelevant and crucial major part of replacing traditional life into zero waste, cleaner possibility, and more sustainable life. This shows that can be with this education showing in these webinars were very important, because we can, by educating of surroundings, we can convince and transform our people, all people, to replace the common and common and comfortable lifestyle into some less but more, but only on some seconds, because when we convert into more cleaner, more sustainable, the expenses would be firstly afford in the short time, but long after year, 5 years, we see radical improvement of our lifestyle and more better link community, because this more renewable science living requires more linked, more cooperating society with each other. And very important is to publish that can be learned, can be teach. And such article, which I invite you cordially, you can send me the summary of this lecture as I did, and I will compile and send to this paper. I think will be good, very good article, which will be valuable for all of us. Thank you very much. I'm ready for discussion.